Okay, I'm going to kind of skip over some of the where the formulas came from. So as much as I typically like to dive into those, I'm going to skip over that and maybe just make a separate video for it. That way, if you just want to get through it, that's fine, since we are learning at home. Also, this is Secondary Math 3 Honors 8.4 or IB 3.4. So basically what we're doing is, when you have an arithmetic series, so this one up here is because you're adding 5 each time. You might hear my baby's toys. Since we're adding 5 each time, our first term was 3 and our difference is 5. So you can write that as a way to find your terms. And then it's the n minus, my calculator's in the way, n minus 1 times the difference. And then that's going to allow us to find any of the terms. Basically, these are the formulas. They're all actually the same thing. So this is kind of the most common one, is you're going to take your first and last term and find the, add them together, divide it by 2, and then multiply that by how many terms you have. You can factor the 2 out, and then it turns into this. This is also common. But sometimes, since we don't always have the last term and we have to use a way to find the last term, that's where this turns into this, because a subscript n is your, so I'm going to rewrite this one down here, where a subscript n is going to be your first term plus n minus 1 times the difference. And then those just get added together because they're the same thing, and that's where you get the 2 from. So it's the same thing throughout. So I don't care which one you use. And don't memorize them. I mean, it might be helpful on something like the ACT or in the future, but for my class, you don't need to have them memorized. So all it is we're going to evaluate the following. So we could use a calculator for this. It's also going to be annoying, though, just because we're going from, it's a little blurry. I don't know if I can change the focus mid-video. Nope, that's worse. I think that's going to be the best one. So from 1 to 50, that's a lot of terms. So of course we can use our calculator, but we're going to just use some of these formulas. So I'm actually just going to use this one. So the sum of the first 50 terms of this arithmetic sequence is going to be n over 2. So n is how many terms I'm working with, so 50. And my first term and my last term. So I'm going to need to figure out what those are. So my first term is when I plug in 1. So what's 5 times 1? 5. Minus 2 gives you a 3. And then I'm going to add to that my last term. So I take 5 times 50 and subtract 2. And I get 248. So basically I'm taking 25 times 251. And that's what we get. So that's the sum of the first 50 terms. Okay, so then same thing with the geometric sequences. So for a geometric series, we're adding the terms together. I don't know if that's going to stay. And then these are our formulas. So they are the same thing. It's just a fact of if I took this one and multiplied both the numerator and the denominator by negative, which multiplying by negative over negative is not going to change anything because it's just 1. And then distribute that negative into the parentheses, and you get negative 1 plus r, so you write that as r plus 1, and distribute this top one into here. It just switches it places, so I don't care which one you use. I'm used to just this one. So here's our example. So we have n is 1 to 20, 3 times 2 raised to the n minus 1. So we need our first term, which is going to be that 3, because if we input 1 here, 1 minus 1 is 0. 2 to the 0 is just 1. So 1 times 3 is 3. We're also going to need an r and an n. So our r value is what is multiplying each time, so that's the 2. And then the n is where we're going to, so n is 20. Okay, so we're adding up the first 20 terms. So the sum of the first 20 terms is the first term times 1 minus 2, because that's my r value, raised to the n, over 1 minus the r value. Okay, so I'm going to evaluate the numerator and denominator separately. So I'm going to say 3 times 1 minus 2 raised to the 20th, the number. Can you see? Yeah. So negative 3, 1, 4, 5, 7, 2, 5. And 1 minus 2 is negative 1. I didn't need to type that in. So then this will help if the fraction doesn't come out nice like this, to do them separately. But basically, turns out to be 3, 1, 4, 5, 7, 2, 5. Those are commas, not decimals. Okay. Again, we could do this with a calculator by doing math. Go to my summation. X equals 1 to 20, and it was 3. This is where we have to be careful with the parentheses. 2 raised to the x minus 1. Now I didn't put the x minus 1 in parentheses because my calculator is showing me that it's all in the exponent. So if yours doesn't do that, you need to put it in parentheses. So we get the same thing. Okay. So then we have something called an infinite geometric sequence, or series. And that is going to be, I don't know if I want to go through the proof of that either. Let's see. No, I don't want to. Basically, well, we can use the calculator. We'll go through this. So I have this, I'm going to write it out bigger, but I have this summation of n equals 1 to some number, and it's 2, 1/2, n minus 1. And this number's changing, so I'm going to just put a W. I don't know. So when W is 10, our summation is going to be something. When W is 20, our summation is going to be something. When it's 100, it's going to be something. Basically, we're making it bigger and bigger and bigger so that we can kind of see what's happening if it goes to infinity. So I'm going to type in my summation, so math summation x is equal to 1, I switched over, 1 raised to, and this is what we're going to change. So 10, and then 2, parenthesis, 1/2, raised to the x minus 1. So 3.996 stuff. And then we're going to do the same thing, but now we're going to do 20. And 100. It says it's 4, but it's not actually 4. It's because it can't, it's because of how the calculator rounds. So if we do like 50 or something, I'm sure it would work out a little differently. But 3.999, and then it's saying it's 4. What this is telling us is that as W is getting larger and larger and larger, so this notation, I'll rewrite it, is using K. This is, I don't know if we've gone over that in this class, but this is called a limit. Basically, we're saying that this number is approaching infinity. So as we take this number to be bigger and bigger and bigger, we use W, and this one it's K, of this thing, what's happening? It's going to reach 4. So it's kind of like if I said, if I take 1 over x and make x go bigger and bigger and bigger, what is it getting close to? So, well, if x is 1, 1 over 1 is 1. If it's 2, it's 1/2. If it's 10, it's 1/10. If it's 1,000,000, it's 1 over 1,000,000. What's it getting closer and closer and closer to? It's 0. So 1 over x isn't 0, but it's getting, as we take it larger and larger and larger, it's getting closer to 0. That's basically what this is saying. So what's happening is there's 2 different kind of scenarios. The baby wanted to be heard. Something called convergent or divergent. So convergent is when it gets closer and closer and closer to a specific number, and divergent is where it doesn't get closer and closer to a specific number, basically. So if your ratio is less than 1, the absolute value of it, so basically what I'm looking at here is on a number line, if R is here, then it's going to converge. If R is anything else, including -1 and 1, then it's going to diverge. So it's going to get to something, not something. So that's where we have a formula for convergence, because it's going to tell us what it converges to compared to divergent, where it's not actually getting closer and closer to something. So nope, there's nothing to do with it. And I don't have any examples of that. I thought I did. Hold on, let me go see if I can find one. Okay, so I'm going to actually do one from the homework. This is number 5. So it gives us this sequence. And I think it tells us, I don't have the directions, but I think it tells us that it's geometric, so we don't have to check that. But I do need some information. I know the first term is 1/3, And the ratio is going to be taking the second term and dividing it by the first term, which you multiply by the reciprocal. So I get the square root of 3 over 4, which is going to be annoying, but it's a thing. So it wants the sum of the entire sequence. That's what we're finding. Now, basically, I need to decide if it converges, then I have to use a formula. If it doesn't, if it diverges, then there's no solution. So that's always based off of, is the absolute value of r going to be less than 1? So again, back to the thing. Well, let's see, square root of, even if we didn't have access to a calculator, the square root of 4 over 4 is going to be bigger, and 2 over 4 is smaller than 1. So we're good. It's going to converge. So then I need to find what it converges to, and the formula was take your first term and divide it by 1 minus the ratio. So I'm just going to fill in the information. So I have 1/3, 1 minus square root of 3 over 4. And the reason why I'm doing this one is there's a lot of fractions. So I'm going to first work with the denominator. So I'm going to ignore this 1/3 for a second. I need to have a common denominator here. So I'm going to say 4 over 4 minus the square root of 3 over 4. So I get 1/3 over 4 minus the square root of 3 over 4. Then I'm going to come and actually multiply by the reciprocal. So I'm going to take my 1/3, multiply by the reciprocal, and I get 4 over 3 times 4 minus the square root of 3. Okay, I will take that answer. That's just fine. There are going to be situations where they want you to distribute the 3, or they want you to not have a radical in the denominator. So if you want to look at my solutions online to kind of walk through that, great, go for it. But I would take that. That's fine. Okay, and then I'm going to do, we have like one more slide left, but I'm going to do that in a separate video because I also need to do other things right now. So, next video.